30. Determine if the number below is rational, an irrational number, or is not a real number. If it is a rational number, simplify. If the square root is an irrational number, approximate the square root to the nearest whole number. The square root of 53. So 53 is not a perfect square like 4, 9, or 16. And 53 is close to 49, which is a perfect square and has a principal square root of 7. Now, 8 squared is 64. So the principal square root of 64 is 8. Now 53 is closer to 49 than 64. So the square root of 53 is approximately 7. A principal square root is a non-negative number, a number that's positive or 0. And the principal square root is such that when you square the square root, it equals the radicand. But for the square root of negative 87, there is no real number that you can square and have it equal negative 87. So every time we have the principal square root of a negative number, the answer is not a real number. And we can use symbols to express this. Is not an element of the set of real numbers. 31. In a right triangle, the hypotenuse has length 13 units and one leg has length of 5 units. Find the length of the other leg. In a right triangle, 2 legs are mutually perpendicular, forming a right angle. And across from the right angle is the longest side, called the hypotenuse. And the other 2 sides that are perpendicular are called legs. The legs have length A and B, and the hypotenuse is always length C. And the relationship between A, B, and C is that the sum of the squares of the legs is equal to the square of the hypotenuse. So here we have one leg is 5 units, so let's say A is 5. The other leg is unknown, we'll call that B, and that equals the hypotenuse length, which is 13. 13 squared. So to solve for length B, let's square 5 and square 13. Subtract 25. Thus, B squared equals 144. Now there's 2 solutions for B. And when we take the principal square root of both sides, we have a technicality that the square root of B squared is always non-negative. So you're going to have absolute value bars around the B equals 12. This absolute value equation has 2 solutions for B. B can be positive or negative 12. But since B is a length, B cannot be negative. So the final answer is B is positive 12 units in length. (32) Find the area and circumference of a circle with radius square root of 3. The formula for area of a circle is pi times the radius r squared. So substituting square root of 3 for radius squared. We get times 3 or 3 pi square units. Circumference C is 2 pi r equals 2 times pi times the square root of 3. And that's perfectly correct as an answer. And circumference is a length, so just units versus square units for area. 33, find the area of a triangle with height 8 centimeters and base 9 centimeters. Formula for area of a triangle is base times height divided by 2. So B for base, H for height, divided by 2. So by substitution, area is base 9 centimeters, height 8 centimeters divided by 2. So area is 9 times 8, 72, divided by 2, 36 centimeters squared. Find the radius of a circle if its area is equal to its circumference. So if the area of a circle is equal to its circumference, and formula for area of a circle is pi r squared, that is equal to 2 pi r. So we can divide both sides by pi. That will eliminate pi. And then we'll want to solve for the radius. So we have a quadratic equation in the variable r. So we'll subtract 2r from both sides, set to 0, and solve by factoring. The greatest common factor is r times r minus 2 equals 0. Set each factor to 0. R is 0, or r minus 2 equals 0. Radius equals 2. But radius is a length, and the radius of the circle will not be 0, so the only solution is radius is 2 units. Determine whether the two triangles are similar. Similar polygons means similar in shape, and the symbol for similar looks like a tilde. And similar shapes will have corresponding parts that are congruent or equal in measure. So the missing angle can be found since in a triangle, all three interior angles add up to 180 degrees. So 25 plus 100 subtracted from 180 will allow us to figure out the missing angle. So this is 180 minus 1.5. So the missing angle is 55 degrees. Label both angles 55 degrees. So since all three pairs of corresponding angles are equal in measure or congruent, these two triangles are similar. (36) The following triangles are similar. Find the length x. So since the two triangles are similar, their corresponding sides are proportional. The triangles are oriented in the same direction, so we don't have to rotate or flip either triangle. Now, say a little bit more. Triangle ABC, those three letters are labeled counterclockwise. So we'll label the vertices D, E, and F. So we're given that triangle ABC is similar to triangle DEF. And that means again that their corresponding sides are proportional. That means we can write a proportion, which is two equal ratios. Now we want to solve for x, so we want to compare x to 1, or side AB compared to side DE, and write the equation x is to 1 as 12 is to 4. Or x equals 3. So here to solve for x, we did not need to use the cross product rule or use any real algebra to solve for x. Now, if we want to go a little bit further, since triangle DEF has its angles labeled, we can say in triangle ABC, we know that angle A has a measure of 90 degrees, so we can write the measure of angle A is equal to measure of angle D equals 90 degrees. Since angle B is congruent to angle E, they have equal measures. So measure of angle B equals 55 degrees. And lastly, since angle F is equal in measure to angle C, angle F, angle C have equal measures, so the measure of angle C is 35 degrees.